Hi friends, welcome back to my channel. So today we will be discussing, is there any sine vibration test which is equivalent to a random vibration test? It's a very sought after question in the field of dynamics and vibration testing. Why? Because sine vibration test is easy to carry out, and even though a random vibration test is very close to the field environments or very close to the real life, it's really expensive and complex. So the question is there an equivalent sign test? As in most vibration problems, let us take the example of a single degree of freedom system as shown over here in this figure. So it is subjected to a base excitation like this. So this is a broadband random signal. So we are giving this as an input and the output will look like this. Behavior of these two signals are different. So this is a narrow band random signal. Why this is a narrow band random signal? We will look into that in a minute. Before that, let us quantify in random vibration testing. We will quantify this input signal not in terms of amplitude versus time, but in terms of PSD. So assume that this is the PSD corresponding to this input. So it's a wide band random signal because it has energy content ranging from 0 to 2000 hertz. So the input RMS is a quantity used to quantify the energy content in the signal. So this particular signal, the input energy will be 10 grms. How you got that I have explained here in this with the help of these equations. Now let us see what is a single degree of freedom system. A single degree of freedom system can be thought of as a narrow band filter. Why it is called as a narrow band filter? Because even though the input signal has lot of frequencies, the output will have only a very small bandwidth of frequencies which is centered about the first natural frequency of the system. Single degree of freedom system has one natural frequency. So I hope now it is clear why a single degree of freedom system can be always thought of as a narrow band pass filter. But the question we are trying to address here is that what is an equivalent sign test for this particular scenario? So assume that this particular system has a natural frequency of 200 hertz and assume that magnification factor Q is equal to 10. So the corresponding damping will be 5% damping, or the damping factor we are assuming is 0.05. Now if we use Miles equation, then we will get the energy content or the output GRMS in the response. So that works out to be 12.5 GRMS. So this is how the response signal will most likely look like, and its energy content will be 12.5 grms. Now we will talk about two possibilities. One, think about an equivalent sign test which will match the same output grms, and scenario number 2 will be we will have an equivalent sign test where we will match the input grms. Start with option 1 where we will match the output grms. So here what I have shown is an sine signal, pure sine signal, whose GRMS value is also matching with the narrowband random signal 12.5. But here you can see there are certain peaks here which is not there in the equivalent sine signal. So the damage potential will be more when your system, when your hardware is subjected to this response compared to this. So that's a big difference. So the RMS value of both signals are same, but the first one has higher damage potential because amplitudes are high. Now let's think of the second possibility. So this was the input signal to the random vibration test, whose input was 10 grms. Now think of a sine test equivalent. So this will be the signal, this will be the input. Now we are matching the input grms. So now instead of the broad band random signal, input will look like this, a simple sine. Now what happens? The response of this system for the same parameter with a natural frequency 200 hertz and a magnification factor of 10, then your response will look like this. Now you see the amplitude has gone up and the RMS value has also gone up. So in a nutshell, this is over testing. This damage potential of an equivalent sign test will be more high here. To sum up, if we match the output RMS value, then damage potential is less. But if we try to match the input RMS, then damage potential is way higher. So let us summarize. That damage potential from a random vibration test cannot be easily simulated in a sine vibration test. That's the message. Before I wind up this video, random vibration tests are also used as stress screening test. What are stress screening tests? They are used to bring out the failures due to poor workmanship. They are not to evaluate the ruggedness of the design. They are just good enough to bring out the failures due to poor workmanship. They are also called as acceptance tests. One major reason why random vibration test is used as a screening test is because at the same time random vibration will provide energy to the system across all frequencies. So the interaction between multiple modes and everything can be clearly brought out in a random test, unlike a sine vibration test. So to sum up, there is no equivalent sign test for a random vibration test, wherein the damage potential of both tests will be the same.